Friends, today we are going to discuss a very important topic of governing system, that is the principle of governing system. The picture depicts here that you see there is a driver which we call the governor, and in front of when he's driving he can see in the roadside that the speed limit that is 60. It was at present is mentioned 60, that is the desired speed, 60 kilometer per hour. And in his speedometer he can see the actual speed the car is running. When this actual speed is if the actual speed and the speed limit is same, then the fuel is constant. But if the actual speed is greater than the speed limit or less than speed limit, then he has to either accelerate or or he has to brake to control the fuel. Now, when he suppose he's ascending in a hill, the roadside he can see the speed limit is 60, and naturally when he's ascending the hill, speed will come down. So his actual speed speedometer will show lower than 60. So she has to increase the fuel to increase the speed, so that speed. And when the actual speed increase the speed, and once the actual speed read the desired speed or the speed limit, he has to slightly cut the fuel so that it should not overshoot the speed limit. Overshoot the speed limit, and that is called to reduce the speed. That is called fuel. That is called reduce the fuel, and that one is called the compensation. In so while descending the load, when he's descending from the hill, his speed limit is 60, and as he descending, so actual speed will be slightly greater than the speed limit. So he has to reduce the fuel and when the actual speed will meet the will equal to the desired speed, he has to further reduce the fuel so that it should not it should not cross the speed limit, and that reduce the fuel, and that is called the compensation. So for decreasing as well increasing, he has to compensate the fuel when the the actual speed reaching the speed limit. So and that so fuel need to be reduced so that it should not overspeed. There are three types of governor. One is called mechanical governor, another one is called hydrodynamic governor, another one is called electronic governor, by which we can control the speed of the turbine. In the mechanical governor, you can see that directly this is the mechanical governor, this is the mechanical governor, and it is directly in between there is a pivot and there is a pilot, there is a steam valve. So when the load increase, speed will come down. When the load increase, speed will come down. When the speed will come down, that flywheel will go to inward, and when go inward, this will move downward against the spring force. It will downward, and then your throttle valve will close, or will further close. And when load decrease, your speed will increase. At that time, you have to close the valve. Speed increase. When the speed increase, it will see it will move upward against the spring force, and due to this pivot, it will come down, and when it will reduce the fuel to the or steam to the turbine. Like this, mechanical governor is working. Similarly, the hydrodynamic working principle is the shaft RPM. This one is the pump. This is the pump. This is the casing. This is the radial hole is there. Two is the primary oil. This is the tachometer, where you can measure the RPM. This is the chamber, oil chamber. This is the oil chamber. Six is the oil inlet. Here it is oil inlet. From here it is oil inlet will come, and this is oil inlet will come. Primary oil, and this is rotating. This one is rotating. This pump is rotating, and when this pump is rotating, we know very well. In the pump section, I have already told you the pressure is directly proportional to the square of the RPM. So P1 by P2 is N1 by N2 whole square. So the pressure will increase when the pressure RPM will increase, pressure will increase, RPM will decrease, pressure will decrease, and that discharge the outlet oil will go to the servo, will go to the transducer. It is act on the, I have in previous topic I have shown you SR4 governors. It will go act outside of the bellow, and as per the pressure, the bellow will up and down, and compensator lever will close and open the sleeve of a follow-up piston, and accordingly the secondary oil pressure will increase and decrease, and your pilot piston and finally servo motor will close and open the valve. This is the working principle of hydrodynamic governor, and this is called SR4 governor, normally SR4 governor, and this one is called the electronic governor. You see the from the shaft we are measuring the RPM, measuring the RPM, and there is a set RPM is there, and compare the actual RPM, and then error which amplify the error. Error means desired minus the actual, it will be plus and minus, so it will amplify the result, and there is a load is also there. Load is similarly there is a set load is there, and if a load is increase and decrease, then error will amplify, and this final connection will go to the electro-hydraulic converter. There out of these two, one is speed, another one is load. The lower value will taken, and this will go to your amplifier, electronic amplifier, and finally to the pilot piston and then servo motor. Accordingly, turbine fuel will be controlled. So these are the three types of governor we normally use in the turbine. Then this is the features that you see from the turbine. We are measuring the RPM. This frequency converter will convert the RPM into frequency to current converter. It will convert the RPM into current. Then pressure controller, you will see the pressure of the boiler and convert it into the current, and then the tool as per the boiler pressure and as per the RPM, they will compare in a controller, and finally the error of finally the lower controller will to take care, will be passed, and then I to H current versus mechanical or hydraulic converter is there, that will give a signal to the throttle valve, and accordingly the valve will close and open the steam valve. How governing system works. Now pressure monitoring boiler pressure changes, pressure monitor that will measure the pressure, pressure controller, and pressure controller, for example, due to high load, pressure will come down, then the pressure controller will give signal the open more valve. Similarly, speed, turbine load increase, speed has come down, so speed controller will say increase the steam flow. So the two the signal will go combine both, single combined, and then the lower speed is this and pressure is maintained, and speed is also to be maintained, and then they think and increase the steam. You just cannot increase the steam blindly. You have to check the speed also, and finally control signal will combine to combined signal will go to I to H converter, and I to H converter means current to mechanical converter, and then electrical to mechanical converter, and then it will go to the signal, give signal to the valve, and valve will open accordingly. Then next is your which signal we are going to take. I have told you the lower signal we are going to take. Pressure controller will care about the steam pressure. Steam controller will take care of the turbine speed. Both trying to control the same thing, that is a steam flow. Then increase when the pressure controller say increase steam. When they increase steam, when pressure is low. When the pressure is low, it will give command increase the steam. Similarly, decrease the steam when pressure is high. Load of the turbine is low. And similarly, speed controller will increase the steam when speed is low. and decrease the steam when speed is high. When turbine load is less, so speed is high, so it will give command decrease the steam. Now the both signal will go to the controller, and then lowest demand wins. Lowest demands means override the higher commands, and then lowest command will be selected. And when they will selected the lower command, that means your turbine will not overspeed, and boiler will also save. Boiler will also save. That is the lower signal, less steam flow. They will give the less steam flow, and this protect the system from overspeed as well as the boiler from overpressure. Overpressure. Suppose the example. Suppose your both are both drivers are running a car. One say go fast, another one say go slow. Certainly, we are going to take the normally we prefer to take the go slow. Similarly, for turbine case, load increases suddenly, then speed will come down. Speed will come down, and then speed controller will give signal that to increase more force. Most 80% stream has to give signal the 80% stream, and then pressure controller will see the pressure drop and say, well, no, increase the pressure, reduce the steam by 50%. So decision of lower selector, 50% pressure controller, 80% speed controller. So we'll select the 50% low controller, and the valve will open 50% to protect the boiler from pressure collapse. Similarly, you see the modification, we can keep both mechanical governor, the PGPL Woodward governor, or electronic governor to control the turbine speed. You see this is the mechanical governor, this is the starting device, function of starting device to open the ESB and keep it under oil pressure. If there is any problem, valve will suddenly close with not only the spring force but also the oil force. So now this is fully open condition, and this starting device will act as a fulcrum. Now as per the speed, the governor will take action, and the lever will move up and down, and accordingly the pressure oil, you see the trip oil will come here, and as per the position of the sleeve, using the sleeve, oil will drain, and the rest of the balance oil will go to the pilot piston. Secondary oil pressure will generate, and this will go to the pilot piston, and pilot piston move up and down, and accordingly the pressure oil will go bottom and top of the servo motor, and control valve will open and close, and accordingly speed of the turbine will be reduced and increased. But this is the mechanical governor. But when suppose you are running the turbine with a electronic governor, then pressure controller will take the pressure of the boiler, speed controller will take the RPM of the turbine, then balance of these two lower controller will select. This will give signal to I2H converter, current versus mechanical converter, and then this will give signal to secondary oil. This will generate secondary oil. Secondary will give signal to mechanical pilot valve, and pilot valve will give from pilot valve position. Depending upon the position, pressure will come up and down to the of the servo motor. Accordingly, valve will open and close, and at that time, if electronic governor will be in operation, a mechanical governor will be closed condition. You see the trip oil going to this system is closed here, as well as the amplifier. From the amplifier also it is closed. So only the electronic governor, you see the trip oil go to the I2H converter, then this line is open, this is give governor to the pilot piston. If this is having problem, then you then trip oil will go. You have to open these two. You have to close this one. You have to close this one. Then you have to take this one online. When you take this one online, this is fulcrum. As per the position, the sleeve will move up and down, and the trip oil will come, and secondary oil pressure will develop, and this will give to the pilot piston. From pilot piston, servo motor, and accordingly the turbine speed will increase and decrease. So only one governing system you can take it online. So either you keep mechanical or electronic. Similarly, mechanical governor, you can see this is the turbine, this is the hydraulic turbine, and RPM is you are measuring. Once the load is decrease, speed will increase. When the speed will increase, this will move up, this will move upward, then this will move upward, means this will close the valve. this will close the valve. When the load increase, speed will come down. Speed will come down. When the speed will come down, you need to increase the load, open the valve, so it will come down. This will come downwards, and this will move upward. It will increase the valve position, and more water or more steam will go. That will maintain the RPM. Now, the previous slide you can see, to operate the steam valve, it is very difficult, because one side will be 101 kg pressure, other side 0 kg pressure. To opening the valve, it requires high pressure. Mechanical governor is not possible. Mechanical governor, it is not possible to increase to operate this valve. So it is to be amplified. That's why the pilot piston we are using. You see the pilot piston we are using. Pilot piston, from pilot piston position of the pilot piston, suppose this is low RPM, high load. This is this is the flyover acting against spring force of the mechanical governor. It will come the centrifugal force. This will move low RPM. It will come inward. When this will load inward, this will move downward. This will move downward, being released. This will move downward. When this will move downward, the oil will go to the pilot piston and for increasing the fuel. For increasing the fuel. But pressure vessel, this is the depends on the area of this. Same pressure oil will go, the area is more, that's why you will get the more force to operate the steam valve or a hydraulic valve, whatever maybe, because the same 8 kg pressure into this area and 8 kg pressure into this area, there is a lot of differences there. So this is, you will get more pressure, more force, and that's why you can open the valve. But what is happening when the turbine, this is the hydromechanical governor, this is hydromechanical governor, this is operating the steam valve, steam valve of a turbine. But when the RPM, it senses the RPM, then when it senses the RPM, high RPM, this will go upward. When this will go upward, this will move up, and when this will move up, pressure oil will go to the bottom and open it. But when it senses the RPM, and then flyover go outside, and pressure oil come inside and then go up, this will take some time. Time lag is there. That's why when the speed is sensed and the pressure will go bottom side of the throttle servo motor, there is a sense, time lag is there. That's why it's overshoot. This cross the reference RPM, set RPM, and then it will increase the RPM. Then when it sends, RPM will increase. When it sends, it will give command to reduce the valve. But once reduce the valve, but by that time, the time lapse is there, so it will cross the reference point and go downward. Like this, the throttle valve, this throttle valve will go on increasing and decreasing, go on increasing and decreasing. That one is called the droop. But and this is go on increasing further. As the time lag will increase, gradually the time lag will increase. We will change the time. It will change the RPM. Then this flyover will move outside. Then pilot piston will move up, and then this pressure will go to the bottom of the servo motor and increase its RPM, decrease or increase the fuel. That will come gradually. This peak will go on increasing like this, go on increasing, and the governor will become unstable. Here it is, hunting is there, and after initial starting of hunting, it will go on. If you keep on running like this, gradually the amplitude will increase, and your turbine speed also fluctuate. That is not acceptable. That is not acceptable. So what we are doing then at that time, we are doing what we are doing. Now we have to change the set point. You see, when turbine will change the RPM, flyover move up or inward, outside inward, signal giving to the pilot piston, oil will go to the bottom and or the bottom side then this will increase. When this will increase, this will change the set point of the spring. It will increase. This will set the either release or increase the spring stiffness. You see, then when the spring stiffness will reduce the set point. You see, when load is added, to the turbine, speed will come down. When the speed will come down, you give command. Actual speed will come down to increase the to open the valve, to open this open this valve to increase the RPM. But at the same time, what you are doing, you are reducing the reducing the stiffness so that the speed will come down and the it's overshooting. Earlier it was more, so more. Here it is come down and it will become steady. So you see the when your load is increased, speed will come down, but hunting will not be there. Earlier case, your set pressure is set RPM is this, then it will go up, again down, go up, again down, and gradually it is more up and down. But here, what we are doing, we are instead of moving upward, we are bring down the set point so that the fluctuation will be very less and it become less. So when we added the load, we have to reduce the set point, and when we are remove the load, speed will increase. At the same time, what we are doing, we increasing the spring stiffness so that the overlapping and fluctuation will be less. That is called the droop. You see at the low load, you see the whole load is not there, speed is increasing, so speed is increased, and setting, and when the load is applied, speed has come down. You see the speed has come down, so we are actually changing the by this. Earlier there this lever was not there, now this, as the lever is there, it will move up, so it will move this one up. When it move down, it will move this spring stiffness will increase. When you move upward, stiffness will decrease, and accordingly the set pressure, set RPM will go on changing, and your the droop or hunting will be less. What is droop? Now low load speed, no load speed is higher, and high load speed is lower divided by the rated speed. That one is called the droop. And as per the droop, less droop is preferable. I have already explained in a previous topic that as per NEMA classification, A, B, C, D type of governor, D type governor more sensitive. Yeah, droop is also minimum. So this is the PGPL governor. This is the starting device. Once the valve is open, pressure is developed. Then it is given. It is act as a fulcrum, and as per the RPM, actual RPM, this will come up. This will give the secondary oil pressure, and the secondary oil pressure operating the valve, pilot piston, and then servo motor. And accordingly, the governing valve will go to steam to the turbine. Similarly, if it is a governor, if it is a electronic governor, then pressure controller sense the pressure of the boiler, speed controller sense the speed of the turbine, both give to the converter, and then the lower signal will come, and then they amplify to I and H converter, a current to mechanical converter, finally give signal to the pilot piston starting device. To secondary oil pressure will develop. This will give command to the pilot piston, to servo motor, and this steam valve will open and close. Why electronic governor is much it is the mechanical governor or hydrodynamic governor? Because you see the fluctuation is more, because I have told you once you have to sense the speed, then you have to give signal, sense the speed, then pilot that flyover will come down inward and outward. Accordingly, pilot piston will move up and down, and accordingly the pressure will go up below and upside of the servo motor. That will, there is some lacking is there. That's why it is drooping is hunting is there. You see the hunting. But here you see we can measure the millisecond speed is faster response. Time is in millisecond, speed sense is in millisecond, and that immediately take action. That's why the fluctuation is not there. You see the fluctuation is not there. Steady RPM up and down is there, but steady RPM not so much fluctuation. That's why the governor, electronic governor, is speed control within 1 RPM in DCS using accurate speed measurement and your millisecond faster response. Millisecond it can measure that speed and give signal, so that I give signal, and that's why this hunting or mechanical governor or hydrodynamic governor is not there in the case of a electronic governor. I think I have clear I have touched all the governor, mechanical governor, hydrodynamic governor, electronic governor, advantage of electronic governor because it can change speed very quickly, but in mechanical governor or hydrodynamic governor, sensing the speed and then action, there is time lag is there. That's why it is hunting is there, and during hunting you have to change the set point. That also I have explained you. So I think if you have your concept will be clear if you go through each and every slide. And if you still have any doubt, you can ask me a question, and I'll my mail ID is also there. You can ask question. I can reply you. Thank you.